Dear students, I hope you are all fine and studying well.
Today we will discuss chapter 5 of class 10th, that is arithmetic progression.
Dear students, let us consider the following list of numbers 1, 3, 5, 7, 9 and so on. Second list 20, 15, 10, 5 and so on. -3, -2, -1, 0, 1 and so on. Each of the number in this list is called a term. In all these lists, we can see that the succeeding term can be obtained by adding a fixed number to the preceding term. In the first list, we can see that each succeeding term is obtained after adding 2 to the preceding term. So you can easily guess the next term 1, 3, 5, 7, 9 and the next term will be 11, then 13 and so on. In the second list, we can see that the succeeding term is obtained after subtracting 5 from the preceding term, that is 20, 15, 10, 5. The next term would be 0, then -5, then -10 and so on. In the third list, -3, -2, -1, 0, 1. So we can easily see the pattern that each succeeding term is obtained after adding 1 to the preceding term. So we can easily write some next terms 2, 3, 4 and so on. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of the arithmetic progression. Remember that it can be positive, negative or 0. Such list of numbers is said to form an arithmetic progression. Let us denote the first term of the arithmetic progression by A1, the second term by A2 and so on. Its nth term is denoted by AN. If we represent the common difference of an arithmetic progression by D, then D can be obtained by subtracting first term from the second term, similarly by subtracting the second term from the third term, similarly subtracting third term from the fourth term and so on, or we can subtract n-1 term from the nth term. If we represent the first term of an AP by A, then the second term of that AP will be written by A plus D. Now we can see that the third term of the same AP can be represented by A plus 2D and the fourth term will be represented by A plus 3D and so on. Now we can see that there is a specific pattern in these. We can write the second term as A plus 2 minus 1 into D, first term as A plus 1 minus 1 into D, third term as A plus 3 minus 1 into D and fourth term as A plus 4 minus 1 into D. Now we can see the pattern and we can write the nth term, that is equal to A plus n minus 1 into D. Note that if an arithmetic progression has only a finite number of terms, Such kind of an arithmetic progression is called a finite arithmetic progression. If the terms are not finite, that is infinite, then they are called infinite arithmetic progressions. Such arithmetic progressions do not have a last term. Dear students, we can also denote the arithmetic progression by AP. Let us solve some problems based on AP. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2 and so on. Write the first term A and the common difference. We can see that the first term of this AP is 3 by 2. To obtain common difference, we can subtract first term from the second term of this AP. We can also subtract second term from the third term and so on. Let us find the common difference D by subtracting the first term from the second term. That is 1 by 2 minus 3 by 2. That means minus 2 by 2. That means minus 1. We can also obtain the common difference by subtracting second term from the third term. That means minus 1 by 2 minus 1 by 2, that is minus 2 by 2, which is equal to minus 1. Hence, the first term of this AP is 3 by 2 and the common difference is minus 1. Dear students, let us solve one more problem. Write first 4 terms of the AP whose first term is minus 2, that is A1, which is A, it is equal to minus 2, and the common difference D is equal to 3. Now, let us try to write the first term, that is A1, which is equal to A, which is minus 2. A2 is given by A plus D, that is minus 2 plus D. That means minus 2 plus 3, which is equal to 1. Third term is written by A plus 2D, that is equal to minus 2 plus 2 times 3, which is equal to minus 2 plus 6, which is equal to 4. Now we can write the fourth term of this AP, which can be given by A plus 3D, which is equal to minus 2 plus 3 times 3, which is equal to minus 2 plus 9, which is equal to 7. So we have found the first term of this AP as minus 2, second term as 1, third term as 4 and fourth term as 7. You can easily see that the common difference of this AP so obtained is 3. Dear students, now let us discuss about the nth term of an AP. The nth term AN of the AP with first term A and common difference D is given by AN is equal to A plus N minus 1 into D. Dear students, now let us discuss few problems based on the nth term of an AP. Determine the AP whose third term is 5 and seventh term is 9. Let the first term of an AP is equal to A and the common difference is equal to D. Then according to the given problem, A3, that is the third term of an AP, is equal to 5 and A7 is equal to 9. This means A plus third term is written as A plus 3 minus 1 into D, which is equal to A plus 2D. This is given to be equal to 5. Now we'll give this equation number 1. Now seventh term is 9. This means A plus 7 minus 1 into D is 9. This implies A plus 6D is 9. Let us give it equation number 2. Now let us solve these two linear equations in two variables a and d to find a and d. So we can use elimination method to find the value of a and d. Now a plus 6d is 9. Let us subtract these two equations. So we will get minus 4d is equal to minus 4, that is d is equal to 1. Now let us substitute this value of d in any of the above equations to find the value of a. That is a plus 2d is equal to 5. This implies a plus 2 into 1 is equal to 5. That means a is equal to 3. Now we got the first term and the common difference of the AP. That means the first term is 3 and the common difference is 1. That means we will add 1 to the consecutive terms. The first term is 3, the next term will be 4 and the next term will be 5 and so on will be the terms of this AP. Dear students, let us do one more problem. Which term of the AP 3, 8, 13, 18 and so on is 78? Now we can see that this is the AP with first term a is equal to 3 and the common difference d given by the second term minus first term is equal to 5. Now the nth term of this AP can be supposed as 78. If we are able to find the value of n as a natural number, then there must exist a term 78 in this AP. Now let us find the nth term of this AP, which we have equated to 78. Now we can find the value of n because we know the value of a and d. Now this is n minus 1 into 5 is equal to 78 minus 3. That means n minus 1 into 5 is equal to 75. That means n minus 1 is equal to 75 divided by 5. That means n minus 1 is equal to 15. That means n is equal to 16. So we can say that 78 is the 16th term of AP 3, 8, 13, 18 and so on. Dear students, let us do one more problem. For what value of n are the nth terms of the APs 63, 65, 67 and so on and 3, 10, 17 and so on are equal? We have to find the nth term of this AP and the nth term of this AP and equate it to find the value of n. So nth term of the first AP is given by a, its first term a is 63 plus n minus 1 into d, its common difference is 2, and the nth term of second AP. So this is for first AP and this is for second AP, that is 3, 10, 17. This is 3, 10, 17 and so on, and this is for 63, 65, 67 and so on. So nth term of the second AP is given by its first term a plus n minus 1 into its common difference, that is 7. Now these two nth terms are equal for one value of n. So we have to find that value of n. So equating 1 and 2, that means 63 plus n minus 1 into 2 is equal to 3 plus n minus 1 into 7. That means let us take n on the left side and the constant terms on the right. So we will get 2n minus 7n is equal to 3 minus 7 minus 63 plus 2. So we will get minus 5n is equal to minus 65. That means 5n is equal to 65. That means n is equal to 65 divided by 5, which is equal to 13. So that means for n equal to 13, the nth term of these two APs are equal. Dear students, now let us find the sum of first n terms of an AP. The AP is A plus D, A plus 2D and up to A plus n minus 1 into D. Now let us take an example to understand the sum of an AP in a better way. Let us consider an AP having numbers 1, 3, 5, 7, 9, etc. So let us write the sum of this as S. So 1 plus 3 plus 5 plus 7 plus 9 is the sum of this AP. Now writing these terms in the reverse order, we will write 9 plus 7 plus 5 plus 3 plus 1. When we add these two equations, we will find a very interesting fact that on the right hand side, when we add these terms, 1 plus 9, we will get 10. And when we add second plus the second last term of the AP, that is 7 plus 3, we also get 10. So in this way, all the terms will be same. That means now it is very easy to add all these terms. That means now we can find the sum as 10 into the number of terms, that is 1, 2, 3, 4 and 5. So we can easily find the value of S, which is 10 into 5 by 2. So in this way, we will find the sum up to n terms of an AP. Now let us consider S as the sum of first n terms of this AP. A plus D, A plus 2D and so on up to A plus n minus 1D. Now writing this in the reverse order, that means first we will write the last term, that is A plus n minus 1 into D. Then we will write the second last term, that is A plus n minus 2 into D and so on up to A. Now adding these two equations, we will get the LHS is equal to 2S and the right hand side as 2A plus n minus 1 into D plus again 2A plus n minus 1 into D and so on up to last term, that is again 2A plus n minus 1 into D. So this is n times addition of the term 2A plus n minus 1 into D. That means 2S is equal to n times 2A plus n minus 1 into D. That means S is equal to n by 2 2A plus n minus 1 into D. So we are able to find the sum up to first n terms of an AP. Now if we consider that the last term of the AP is the nth term, that means we can split this as n by 2 A plus n minus 1 into D. We split 2A as A plus A. Now we can say that the nth term A plus n minus 1 into D could be the last term of the AP. Then we can easily say that this formula changes to A plus L, where L is the last term or the nth term of this AP. If we have to find the sum up to n terms, then the last term will be the nth term of this AP. Dear students, now let us find the sum of first n positive integers. That means we have to find the sum of 1 plus 2 plus 3 plus 4 plus 5 up to n. We can use the formula of sum of first n terms of an AP, because we can see that this is an AP with first term 1 and common difference also 1. And the last term of this AP is n. So we can directly apply the formula Sn is equal to n by 2 first term plus last term, that is 1 plus n. Now we can use this formula directly as n into n plus 1 divided by 2. For example, if we have to find the sum of first 10 natural numbers, that is 1 plus 2 plus 3 plus 4 up to 10, we can easily write this as S is equal to N, that is 10, into 11 divided by 2, which is equal to 55. So we can directly apply this formula n into n plus 1 by 2 for the sum of first n positive integers. Dear students, let us do one problem. In an AP given by A is equal to 5, D is equal to 3 and n term is 50, find n and Sn. We are given an AP whose first term is 5, common difference is 3 and n term is 50. So we are given An is equal to 50, that means A plus n minus 1 into D is equal to 50. That means 5 plus n minus 1 into 3 is equal to 50. That means n minus 1 into 3 is equal to 45. That means n minus 1 is equal to 45 divided by 3. That means n minus 1 is equal to 15. That means n is equal to 16. So the value of n is 16. Now we have to find the sum up to n terms of this AP. With first term A 5 and common difference D 3 and n equal to 16. We apply the formula n by 2, 2a plus n minus 1 into D to find the sum of n terms. That means n by 2 is 16 by 2, 2 into a, that is 2 into 5 plus n minus 1, that is 15 into D is 3. So we get 16 by 2, that is 8 into 10 plus 45, that is 8 into 55, that is equal to 440. So the answer to this question is n equal to 16 and Sn is equal to 440. Dear students, let us do one more problem. Find the sum of first 22 terms of an AP in which common difference is 7 and the 22nd term is 149. That means D is 7 and A22 is 149. This means A plus 22 minus 1, that is 21 into D is equal to 149. But we know the value of D. That means A plus 21 into 7 is equal to 149. That means A is equal to 149 minus 147, that is equal to 2. So we got the value of the first term, that is A is equal to 2, and we already knew the value of D, that is D is equal to 7. Now we can find the sum of 22 terms of this AP, that is given by n by 2, 2a plus n minus 1 into D. Now the value of n is 22 here, the value of A is 2 and the value of D is 7. The value of n is 22 here, so that means this into 7. That means 11 into 4 plus 21 into 7. That means 11 into 4 plus 147. That means 11 into 151. Now, answer will be 1661. Hence, the sum of first 22 terms of this AP is 1661. A sum of rupees 700 is to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is rupees 20 less than its preceding term, find the value of each of the prizes. Dear students, we are given that the sum of 7 cash prizes is rupees 700 and the common difference of this AP will be minus 20, as each cash prize is 20 less than its preceding prize. That means D is minus 20. So we can apply the formula S7 is equal to 7 by 2, 2a plus 7 minus 1 into D, that is minus 20, to find the value of A. Now S7 is 700, that means the first sum of first 7 terms, that is 700 is equal to 7 by 2, 2a plus 6 into minus 20. That means 200 is equal to 2a minus 120. That means 2a is equal to 320. That means a is equal to 160. So the first prize is rupees 160. Hence the first prize is rupees 160. Second prize A2 will be 20 less than this prize, that is 140. Third prize will be rupees 120 and so on. Dear students, I hope you must have understood the chapter thoroughly. Thank you.